Welcome back. Thank you for rejoining me for your next notes video. Today we are going to finish up our notes on 6.1, roots and radical expressions. So today we are going to continue our conversation on taking nth roots, okay? However, today we're going to introduce variables into these. So you're also going to be able to take the root of variables with an exponent. Now, something to consider, all right? So, nth root of variables. Now, when n is odd, doesn't change anything. So remember last time we talked about that plus and minus stuff? Well, again, when it was odd, didn't matter. Same thing with this rule, okay? It only matters when it's even. When n is even, you must include absolute value signs. All right? To make sure that we're discussing the principal root. With exponents, you don't know if you're, or with variables, you don't know if you're talking about a positive or negative number. To ensure that we're talking about positives with those even roots, that means we need to take that absolute value. All right? Now, aside from that little caveat, it's actually not too difficult to solve these problems. So the first step is take the appropriate root of the number. And today you're going to be given all nice numbers, okay? We're starting off the easy way. We're starting off with all numbers that are going to have a nice root that I'm asking you to take, all right? And then the second step is I want you to divide the exponent of the variables by the index of the root, or that n value. All right? Now, remembering, if no index is showing, we're talking about 2, a square root. All right? So again, a little bit wordy to begin with, kind of difficult to understand until you really jump into an example. So, let's start with some. We're going to simplify each following radical expression. So, the square root of 16x to the 8. Now, you guys probably know this one off the top of your head. Square root of 16 gives you 4. X to the 8. Now remember I said, whenever you have an exponent, you're going to divide it by the index, by that n. Well, in this case, a square root, we're going to be dividing that 8 by 2. So 8 divided by 2 gives you 4. Now this has an even index. So I'm going to start by putting my absolute value sign there. Now I said start by putting it there because now we need to consider, does it actually need it or not? All right. So the number 4, whenever you have a number, the number actually never needs to be inside an absolute value. All right. Because the number 4 doesn't ever risk being negative, does it? It's already the positive number 4. I also want you to consider x to the 4. Anything to an even exponent is automatically going to be a positive number. All right, so in this case, none of it actually needs to be inside the absolute value because you know already it is going to be an even or a positive number. All right, so in this case, I want you to consider the fact that you have to wonder about the absolute value. But in this instance, all of it actually comes out of the absolute value because you know it's going to be a positive number anyway. This one has an odd index. So this one we get to skip that absolute value conversation altogether because it's odd. So all you have to do, cubed root of 27, type that into your calculator, you should get the number 3. A to the 6, again, you divide the exponent by the index. So 6 divided by 3 leaves me with an a squared. B to the 9, well, 9 divided by 3 leaves me with 3. And that is what I get. All right, again, because the index is odd, I don't consider the absolute value. That is actually all that you have to do. All right, here we are back to an even index. So the fourth root of 625, do that on your calculator, you get the number 5. whenever you run into an exponent, so x to the 8, well, divide that by 4. You get x to the 4. For the y, 12 divided by 4 leaves you 3. And because it's an even index, we're going to take the absolute value of it to ensure we're getting a positive number. However, just like the first example, let's consider what actually needs to be inside that index or inside that absolute value. What doesn't need to be inside that absolute value? Well, the number 5 is automatically positive. You don't need that number inside the absolute value. X to the 4, you're taking something to an even power, so that is automatically going to be positive as well. The only thing that we have to worry about here is that y to the 3. If y is negative, y to the 3 would be negative, and that's what we need to be cautious about. So when you have an odd power, you need to leave it inside that absolute value. Okay? So the most simplified solution is going to be this. This is what I need you to be able to get to on the test. All right? You need to be able to consider what can pull out of the absolute value. What can pull out of the absolute values? Numbers and even exponents. So, moving right along. Let's do a couple more examples just to make sure you're really understanding where this is coming from. All right? So here, this is an even index again, so we have to consider what's happening. Well, square root of 81 is 9. X to the 4 divided by the index is going to leave us x squared. We have to consider absolute value and then consider what takes out or what can pull out of it. A number can come out because we already know 9 is positive. X has an even exponent. We're talking about x squared. So that is automatically going to be positive. So in this case, again, the absolute value just completely goes away because we already know 9x squared, no matter what, is going to be a positive number. All right, here is an odd one. So in this case, we don't need to even worry about that absolute value. All right, so we just do our operation. The cubed root of 8 gives you 2. Cubed root of 8 to the 12, well, divide. 12 divided by 3 leaves you 4. B to the 15, again, divide by that index, leaves you b to the 5, and we're done already. All right, now here is another even case. So the fourth root of 16 is 2. X to the 12, again, divide. 12 divided by 4 gives you 3. Y to the 16, we'll divide 16 by 4, leaves you 4. And again, because that index is even, we need to consider the absolute value of our answer. So let's see what comes out of our absolute value this time. Well, the 2 comes out because it's just a number. Y to the 4, because it's to an even exponent, that is always going to be even automatically. It is that x to the 3 that we need to be wary about. Okay, the x to the 3, be cautious about because it has an odd exponent. So if x is odd, x to the 3 would be odd. So we leave it inside the absolute value. All right, so moving along, let's talk about a word problem really quickly, okay, to wrap up our notes. So some teachers adjust test scores when a test is difficult. One teacher's formula for adjusting scores is A equals 10 times the square root of R, where A is the adjusted score, R is the raw score. If the raw scores on one test range from 36 to 90, what is the range of the adjusted scores? All right, so we're talking about an R of 36 ranging to an R of 90. and we want to know what's the range of A, okay, the range of those adjusted scores. Well, let's plug it into the formula, shall we? So that means we're going to be ranging from 10 square roots of 36 to 10 square roots of 90. All right, now, because we're talking about a word problem here, we're not going to be simplifying these radicals, leaving in a radical form. We want to know point-wise, right? So in real-world circumstances and word problems, make sure you are actually getting like real decimal answers. What would a calculator tell you? So you're 10 times square root of 36. Well, you should already know the square root of 36 is 6. So that would lead to an adjusted score of 90. Now, square root of 90, that one's not so nice. When you take the square root of 90, that's giving you 9.49 blah, blah, blah. Okay? That's what I mean. We're not going to be simplifying the radical in this case. You're just going to tell me what the calculator would give you. Multiply that by 10. So you can tell me that the adjusted score is going to range between 60 and 94.9 for these adjusted tests. All right, so that is going to be all for our notes today. Again, I thank you for joining me. Now, make sure you have all of this written down, all right? So skim through, make sure you have everything. When you do, you can turn off this video, come back to class tomorrow, prepared to work on the practice work associated with this section. So again, thank you for your time, and I'll see you to do your practice work in class.